Hello class, and welcome to lesson 2.4, midpoint of the line segment. Here's our warm-up today, and look at this drawing. It's pretty fascinating actually. It says, what is this drawing and what mathematical properties are used to create it? So first of all, I'm going to focus on the outside triangle. Okay? It's the biggest one there is. And then I'm going to look at the next biggest one. And I want you to see if you can develop a property based on that. Okay. Now you might say, hey, Miss R, there's four triangles inside the big one. But I'm just focused on these endpoints. So where are these endpoints meeting? Hopefully you realize they're meeting at the midpoint. Okay. So when you take a diagram and focus on the midpoints, and then you focus on the midpoints, and then you focus on the midpoints, you focus on the midpoints, and you keep going, you're going to create something that's called a fractal. And you're going to say, what, Miss R, what's a fractal? Well, anyway, you have, I'm pretty sure I can guarantee that you have sang a song that has fractals in it. And here's the key lyric. So let's play, what's that? What's this lyric? Or remember that TV show that Wayne Brady is in? Sing that song or sing the tune. Anyway, so you should know that you sing a song called In Frozen Fractals all around. Okay, and it's very popular, guys. My daughter loves this. Anyway, if you need a hint and you're like, Miss R, I've never heard of fractal, I guarantee you've probably sang it. And here's a link. Hopefully it'll work. See if I get the volume up here, guys. Oh, of course we have to skip an ad, so just hold on. I'll give you a musical interlude. Do. Okay. Okay. So, ladies and gentlemen, from the movie Frozen, my daughter Grace would be so proud to introduce you a math term. So, do you guys now remember that fractals are in here? Just going to see if I can move it up to where it actually is. Let's see if I can use it. Sorry guys, that was the alarm. Let's see if I can... I'm trying to remove my ink layer. I'm trying to close it and see if this will work. Huh. Okay, so here's where it's starting to get interesting. If the sound doesn't work on this, by all means, Google it, guys. So, snowflake is based on a fractal, just in case you're wondering, guys. And so is this lovely ice sculpture. All right, here comes the big line. Get ready. Here we go. Frozen fractals all around. Woohoo! So you guys can Google that anytime you want. So there you go. Disney actually has a math term in it. So isn't that cool? All right, I'm going to turn this off now, if I can. All right, so that was all fun. You guys can watch that a little later. I actually want you to Google images of fractals. So let me just show you quickly, guys, what it looks like, because these are pretty cool. You might even want some of these in your class, or not in your class, in your room. They're pretty cool. So if you look at some of these and you Google image some of these, it's pretty cool, guys. So take a look at some of these neat images. So you can get fractals in nature. So things like certain types of cauliflower, shells, they do fractal arrangements. I'm just going to see if fractals in foods. There's like a cauliflower example right there. But it's really cool, guys, this fractal development. So if you ever want to check it out, there's some cool math stuff that looks really awesome. A lot of people have tried to do tattoos with fractals, and they're very hard to do. But anyway, there's cool fractal stuff. All right, so now we're taking a look, and it's all, again, based on midpoints. Okay, I'm just going to pause for a sec. All right, sorry about that, guys. I'm back. So again, have some fun looking at some fractal images. It's pretty cool. Fractals in nature is also really cool. Taking a look now back on our lesson. I know that was the fun part. Now we're going to get to doing some more of the work part. Okay, so it says Sarah is planning to run a race, run a 25-kilometer marathon, and Joan only plans to complete half of the race. Mathematically show how far Joan will run. So many of you would say, hey, Miss R, the total is 25 kilometers, and we're going to divide by 2 because she's going to run half of it, and you would say 12.5 kilometers. Another approach I want you to take a look is the starting value for the race is 0, and the ending value for the race is 25. So you could also say 0 plus 25, taking the start to the end distance, dividing it by 2, and that's going to equal 12.5 kilometers. The reason why I'm asking you to do this method is because this is how we're going to be setting up our midpoints that we're going to be learning how to do. All right, here's another example. Calculate the average of 45% and 68%. So you take your two averages, or 2 marks, and to average them, you do what? You add them together and divide by 2. So plug in your calculator, you're going to get 56.5%. Awesome. So that's basically what we're going to do today, folks. We're going to be taking a look at the midpoint. We're going to add 2 things together and divide by 2. So here's our title, 2.4, midpoint of the line segment. It is easy to find the halfway point when we know the starting and the end point. So if we start at 0 feet and Miss R runs 200 feet, where's the halfway distance? Again, you take the start, add the end, and divide by 2. Okay? But what happens when each point is a coordinate? For example, in a race, that's just linear. That's a straight line. But what about if we add a dimension to it? So if we have x and y, our midpoint formula changes, ladies and gentlemen, because we have a vertical component and a horizontal component. Okay? So all we do, folks, is based on the same x1, y1 for the first ordered pair and x2, y2 for the second ordered pair, the same as we did for length and slopes, folks. The midpoint, which is capital M, okay, is the addition of the x's divided by 2 and the addition of the y's. If you think about it, ladies and gentlemen, okay, I need to compensate for my vertical distance and my horizontal distance. So just remember, x1 plus x2 is going to be total horizontal. So that's your horizontal displacement, but you got to take it and divide it by 2. Okay? So horizontally, if I go like this and I divide by 2, I'm going to be here. Okay? Likewise, for the y's, ladies and gentlemen, that's my vertical distance. So if I take my vertical distance, add them together, that's the total, and I divide by 2. If I take my 2 points and put them together, you will find that you will get at the midpoint. Okay, so this is the formula we're going to use, okay, for the midpoint. All right, let's try some examples. Okay, so example 1, determine the midpoint of the line whose endpoints are A and B. For those who need it, x1, y1, x2, y2. Okay, so midpoint is capital M, lowercase ab, equals, you're going to add the x's, so -2 plus 8 divided by 2, comma, -6 plus 4 divided by 2, comma. Now, ladies and gentlemen, my biggest communication error here is people forget that this is an ordered pair. So I always start by doing this, by putting in brackets and a comma, so I remember that it's an ordered pair I'm looking for. So let's simplify each fraction, guys. So you're going to have 6 divided by 2, and for the y, you're going to have -2 divided by 2. So simplifying that even further, you're going to have 3 and -1 using your integer laws. Okay, any questions there? Perfect. Make sure for good communication that you have your brackets and your comma. Let's try another one. Midpoint CD. Okay, why don't you try it? Pause and then unpause me. Okay, so pause. Hopefully you paused. Come on, if you haven't paused, pause now. All right, welcome back. Hopefully you paused and didn't cheat. Here's what you should have written down. Okay? So simplifying, folks, you should have 4 over 2 and 10 over 2. And that midpoint will simplify down to 2 and 5. Which is really neat about this, folks, is you don't need to have a graph. Okay? You don't need to plot it and have your midpoint. All right? So that's pretty cool about doing midpoints. Okay? Now example 2, this is a tricky one. And I guarantee you want to study this one for test. So make sure you know how to do this one. As I get people on the test all the time. And you're saying, Ms. R, what's so tricky about it? Well, read this question. It says line segment AB has an endpoint of 7 and -3 and a midpoint of AB. Okay, find the coordinates of the endpoint. So what's tricky is you're not finding the midpoint because the midpoint's given. You're actually finding an endpoint. Okay? And you got to be careful. So what we're actually looking for, we're looking for B, which is X and Y. We don't know what they are, but we're going to find them. You can say, huh? How do we do that? Well, let's just remember what we know. We know that general definition is midpoint of AB in this case equals X1 plus X2 divided by 2 and Y1 plus Y2 divided by 2. Let's sub in what we know. And this is what's strange. We actually know the midpoint value. And we know that it's 1 and 3. So we're going to put that in on the left side. On the right side, we only know part of the puzzle. We know divided by 2. And we know one ordered pair. So it's going to be, we know the X, which is going to be 7. So you're going to go 7 plus X. And we know the Y, which is going to be -3 plus Y. Okay? And now we have to remember something here, folks. By definition, this is an equation. And by definition, the left side has to equal the right side. So if the x coordinate on the left is 1, that means that this fraction on the right, the x coordinate on the right side has to equal 1. Likewise, the y coordinate on the left is 3, which means the expression for the y coordinate on the right also has to equal 3. So we're going to solve these separately. So first thing we're going to do is find x. That's in the red. So on the left side for x, we have a 1. Just for the x coordinate, guys. Okay, on the right side, we have 7 plus x divided by 2. All we need to do is rearrange and solve for x. So we're going to times this by 2 and times this by 2. So we've got 2 equals, these cancel out, 7 plus x. How do you get x by itself? Move the 2 over to the other side. So you're going to have 2 minus 7 equals x. So x equals 2 minus 7, which is -5. Okay, let's find y now. Okay, so looking for y, we're using the y coordinates. So 3 on the left side, which is your y coordinate on the left, equals what we have for the y coordinate on the right, which is -3 plus y, all divided by 2. So again, we want to cancel the denominator. Currently, it's divided by 2, so you're going to times by 2 for both sides. These will cancel out. So we're left with 6 equals -3y plus, -3 plus y, my fault. Okay, to get y by itself, take the -3 over, and it becomes +3. So y equals 9. Therefore, point B is -5 and 9. So make sure when you finish it that you put it in an ordered pair in brackets with commas. All right, ladies and gentlemen. Have fun with your homework. Taking a look on page 89. For number 1, just do line E and F. Don't do the rest of them, just EF. And then 2AB, 4, and 7. And have a great day, folks, and ciao.